so we're going to do some practice on the special parallelogram. So on the rectangles, the rhombus, and the square. All right, so this problem, this is a rectangle in this problem. And they just want us to find the missing measures. So the first measure we had to find is QR, which is the side across from, or the opposite side from PS. So these are congruent, so QR should be 10. SR is opposite from PQ, so they have the same measurement, and that one should be 24 degrees. Okay. The next one we need to find is SQ, which is the diagonal. And because all rectangles have right angles, this now becomes a right triangle where we're looking for the hypotenuse. So we'll call SQX. And so then we have a 10 squared plus 24 squared equals x squared. And then we go ahead and solve that. So we get 100 plus 576 equals x squared. Add them up. 676 equals x squared. Then we're going to take the square root. And that's 26 is equal to x, which means SQ is equal to 26. So we just remember that because now we can start doing right triangle stuff because we know we have right angles. And then so now if I need to find PR, PR is the other diagonal. And in rectangles, the diagonals are congruent, so that makes PR also 26. And then if we want to find QT, QT is a half of a diagonal. Remember, the diagonals bisect each other in every parallelogram. So QT is going to be half of the 26, which is 13. Okay. All right, so let's look at example 2. And this figure is also a rectangle. So to kind of help us out, we know if we're dealing with angles, all rectangles have 4 right angles, okay? So if we want to find the measure of angle MJK, and if you have a hard time seeing it, just trace through the 3 letters. So MJ to K, we're talking about the whole 90-degree angle. So MJK is 90 degrees. And then if we're looking for angle MJL, I'm going to go ahead and erase the green. We'll put the right angles back. If we want MJL, we go from angle MJ to L, so we're talking about this one. And because the 2 pieces together should add up to 90, and we already know the right side of it is 27, so we'll do 90 minus 27, and we get that this angle here is 63 degrees. So angle MJL is 63 degrees. So now they want us to find angle
Good afternoon.
JLK.
Has been canceled for today and rescheduled for next Wednesday, the 20th.
So the next angle we're looking for is angle JLK. So again, if you trace through it, start at J, go to L, and then go up to K. It means we're talking about this piece right here, which will be 63 because it's alternate interior with the other 63 that we just named. And now we want to find angle KML. So let's trace through that. Start at K and go to M and then go to L. Okay. And so how are we going to figure out this angle here? Well, this is how we're going to do this. Well, if this angle is 63 over here, I know this one is also 27. We got alternate interior, or we know the fact that these two have to add up to 90. Because the diagonals are congruent and the diagonals bisect each other, that means this piece of the diagonal is congruent to this one. And if we look here, and I'm going to trace it in red, This triangle formed here then would be an isosceles triangle because you have two congruent sides. And so if those are the two congruent sides, then you know the base angles are equal. So then this angle here has to also be 27 degrees. And then we need angle MNL, which is this angle right here. And so we have a triangle. We know two of the angles are 27. So we can find that angle, which would be 126 degrees, because all triangles add up to 180 degrees. Okay? So the important part here is to make sure you understand that those diagonals, the halves of the diagonals, form isosceles triangles. Okay, let's look at our next example. Now this one is an example of a rhombus. So remember, a rhombus has four congruent sides, the diagonals are perpendicular, and the diagonals bisect the opposite angles. So in this case, I know that JK is 12, and I know that JN is 7. Remember, a rhombus has four congruent sides, so all the sides around would also be 12. So they're asking me for JM. JM is 12. And then for them asking for JL, if JN is 7, then that makes NL also 7. So then JL will be the sum of them both, which is 14. So now we need to find MN. And so I don't want you to think that MN is going to be the same as JN and NL, but this is what we can figure out. If we know this is 7, and we know the diagonals cross at a 90-degree angle because they're perpendicular, then I know in order to find MN, I have this right triangle right here, where 12 would be the hypotenuse and 7 would be a leg and MN would be another leg that we're looking for. So then we have x squared plus 7 squared equals 12 squared, and then we're going to go ahead and solve that. So we get x squared plus 49 equals 144. Then we get x squared equals 95. Take the square root. And x equals 9.7 rounded to the nearest 10th. So that means MN, then it's 9.7. So then if we want to get MK, well, we know that NK must also be about 9.7. So we add them together, and we get 19.4. So remember that when we know the diagonals are perpendicular, so they form right 90-degree angles, so then we can use what we know about right angles to find missing sides. Example 3. This one is also a rhombus, and so we want to find some missing angles. So I'm not necessarily going to move in order, but what I do know is that in a rhombus, the diagonals bisect the opposite angles. Okay, so that means 38 is going to be the same as 3 because that diagonal bisects it. So 3 is also going to be 38 degrees. And so then that would make 38 and 4 going to be the same because they're alternate interior. And then 3 and 5 are going to be the same because they're going to be alternate interior. So those are all 38 as well. Now we know that angle 8 is going to be 90 degrees because all of these angles, all the diagonals bisect at a 90-degree angle. So angle 8 is 90 degrees. I'm actually going to go ahead and fill these in. So 3 was 38 degrees, 4 was 38 degrees, 5 is 38 degrees, and we know that 8 is 90 degrees. All right, so we still got a few more to find. So now I'm going to go find 6 because we have 8, 5, and 6 will be the third angle in a triangle. So we're going to subtract those from 180, and I get that angle 6 is 52 degrees. So because angle 6 is 52 degrees, I also know that 7 would also be 52 degrees because the diagonals bisect, so the angle should be congruent. And then I know that 1 and 2 are also 52 degrees because they are alternate interiors. Okay, so the key points here, knowing that you have 90-degree angles where the diagonals bisect because they're perpendicular, and then letting that help you got triangles, so you got triangle rules, you have alternate interior angles, and then you know in a rhombus the diagonals actually bisect the angles, so you know what both sides of the angles have to be equal. All right, and so now the last two problems we're going to deal with have to deal with squares. So if ABCD is a square and AD, find each missing value. Well, we know squares also have 4 congruent sides. That's an 11. And remember, they have now all the characteristics of rhombus, squares, parallelograms, everything. So if we want to know what the length of BC is, BC would also be 11. So now we want to find AC, which is the diagonal. But remember, we can complete a triangle here, and because it's a square, we know all the angles in the square are 90 degrees. So right here, triangle ADC is a right triangle, and we're looking for AC, which is the hypotenuse. And so now we can solve for AC. So we have 11 squared plus 11 squared equals x squared. 121 plus 121 equals x squared. 242 equals x squared. Take the square root, and we end up with 15.6 is equal to x, rounded to the nearest 10. So now we know that AC is 15.6. And BD is the other diagonal, and in squares, the diagonals are congruent, so BD must also be 15.6. EC is half of the diagonal AC because the diagonals bisect each other. So therefore, EC has to be half of AC, which half of 15.6 is 7.8. Okay, now let's start dealing with the angles. So now we have angle DAB. I'm going to trace through it in green. So DA to B, well, that's the right angle. So DAB is 90 degrees. And then we want to know angle AEB. So let's trace through it. A to E to B. So we're talking about this angle here. And remember, where the diagonals intersect, they are perpendicular. So therefore, that's a 90-degree angle as well. And then our picture is getting a little complicated, so I'm going to erase some of this off. And so now we're looking for angle CBD. CBD, which is this piece here. But you know this angle, the entire angle would be 90 degrees. The diagonals bisect the angles, so CBD must be 45 degrees. And then if I'm looking for angle BAC, I'm looking for this angle here, which is also going to be half of the 90-degree angle, so that's 45 degrees. Okay. And then our last example, if STV is a square with SW equals 2x plus 3, so let's fill that in. SW is 2x plus 13, I'm sorry. And then we know that WU is 8x minus 41, and they want us to find BT. Well, with the information given, we know that those two pieces, those two segments, are congruent to each other because the diagonals bisect each other. So we can set them equal. We got 2x plus 13 equals 8x minus 41. So now we're going to solve for x. we have that 9 is equal to x. So then let's plug it in and figure out what each one of those is equal to. And when I plug it in, I know that this is 31 and this is 31. So then that makes SU equal to 62. You gotta add them all together. Still, we haven't answered our question because we're looking for VT. Now, VT is the other diagonal. And remember, the diagonals and squares are congruent. So if SU is 62, then that makes VT 62 as well. Okay? And so there is all of your practice.